The objective of this lesson is to decompose a fraction into a sum of fractions with the same denominator in more than one way using visual models and equations. In previous grades, students have learned to decompose a number by breaking it into smaller numbers. 10 can be broken into 7 plus 3 or 5 plus 5. Students have learned that using the commutative property allows for changing the order of add-ins when adding. 3 plus 4 equals 7, and 4 plus 3 also equals 7. Students are also familiar with the associative property that allows for grouping add-ins when added. 3 plus 8 plus 2, you can group the 3 and 8 to make the sum 11 and then add the 2 for the final sum of 13. Or you can group the 8 and 2 to make a 10 and then add 3 for the final sum of 13. Students have used models to show that unit fractions can be added to equal one whole. Unit fractions have a 1 for the numerator, and the denominator indicates the number of pieces or items being considered. 1/3 plus 1/3 plus 1/3 equals 1 whole. In this lesson, fractions will be decomposed into fractions other than unit fractions. We will model these steps using Cuisenaire rods. First, let's work with equations that equal one whole. If this brown bar represents 1, then this white piece is 1/8. 8 of these white pieces is the same size as one brown whole. Fractions can also be decomposed into fractions other than unit fractions. We can replace 2 of these white 1/8 unit fractions with a red piece that is equal to 2/8. If 2 white 1/8 are replaced with another 2/8 red, the equation is then 1/8 plus 1/8 plus 1/8 plus 1/8 plus 2/8 plus 2/8 equals 1. What is another way the fractions could be composed? Another equation could be 4/8 plus 2/8 plus 2/8 equals 1. Just replace 4 of the unit fractions with a purple 4/8 piece, and it is still equal to 1 whole. Students are challenged to find multiple equivalent equations that have a sum of 8/8 or 1 whole. Now let's work with fraction equations that are less than 1. If this orange bar equals 1, then the blue bar is 9/10. The addition equation is 1/10 plus 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 1/10 equals 9/10. Replacing groups of 3 white tenths with light green rods represents the new equation, 3/10 plus 3/10 plus 3/10 equals 9/10. Replacing 2 of the 3/10 pieces with a dark green rod would represent 6/10, and the new equation is 3/10 plus 6/10 equals 9/10. Now let's apply this same concept to fractions greater than 1. If the green rod equals 1, then the white pieces are 1/3. This black piece is 7/3. The unit equation is 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3 equals 7/3. If 3 groups of 2 1/3 whites are replaced with 2/3 reds, the new equation is 2/3 plus 2/3 plus 2/3 plus 1/3 equals 7/3. If one of the 2/3 reds is combined with a yellow 5/3, the new equation is 2/3 plus 5/3 equals 7/3. As students explore with fractions, they will develop a deeper understanding and have a good foundation as they move to mixed numbers in future lessons. The objective for this lesson was to decompose a fraction into a sum of fractions with the same denominator in more than one way using visual models and equations. We met this objective by using models to show different ways fractions can be decomposed into smaller fractions and writing equations that have the same sum using fractions with the same denominator.